Okay, so I'm looking at the number and I keep thinking there must be a typo, but there isn't. Everything you have ever seen, every star, every planet, your own hand, that's about 5% of what's out there. 5!
And the rest? A stranger walks into your house and you can only see the furniture in one room out of 20.
Right! And I'm Nadia Frost, by the way. I'll be steering us through this. And I promise you, the deeper we go, the weirder and the more fun it gets.
Victor Lang, and I have to say, I once stood inside an old salt mine, a kilometer underground, where they hunt for this stuff. Freezing cold, dead silent, and everyone whispering like we were in a church. That image never left me.
Daniel Hart, and I'm going to be the one asking, gently but repeatedly, how do we actually know any of this? Because 95% of the universe is invisible is either the greatest discovery in a century or a spectacular embarrassment. And I want to see the receipts. Fair. And honestly, the receipts are the good part. So let's build it up slowly. Daniel, where does the story even start? It starts with people counting. In the 1930s, a Swiss astrophysicist named Fritz Zwicky is looking at a cluster of galaxies, a big swarm of them, all orbiting around each other. And he does a very simple bit of bookkeeping.
The kind of thing you could sketch on a napkin.
Essentially, yes. He measures how fast the galaxies are zipping around, and then he weighs the cluster by its light, how much stuff is glowing in there, and the two numbers don't match. The galaxies are moving so fast, they should be flying apart, like kids flung off a merry-go-round and spun too hard. So hang on, let me make sure I've got the merry-go-round right, because that image is doing a lot of work.
Please, break it.
If you spin a merry-go-round faster and faster, at some point the kids can't hold on. They get thrown off. The only thing keeping them on is their grip, their arms. And for galaxies, the grip is gravity. Gravity comes from mass. So if the galaxies are whirling that fast and not flying apart, there has to be more mass gripping them than we can see.
Way more. Zwicky's cluster needed something like he was off by a lot. His exact number was wrong for technical reasons, but the punchline held. Most of the gravity was coming from something invisible.
And I want to be careful here, because Zwicky is often told as this lone genius nobody listened to. The truth is messier. His measurement had real problems. The value people used for the expansion of the universe back then was off, which threw his numbers. So it's not that he nailed it and got ignored, it's that he pointed at something real with shaky tools. Which I actually love more as a story. Like, he smelled the smoke before anyone could find the fire.
Exactly. And the fire, the thing that really lit the field up, that comes 40 years later, and it comes from a completely different direction.
The rotation curves. This is Vera Rubin. Vera Rubin and Kent Ford, 1970s. And this one I find genuinely more convincing than the cluster because it's cleaner. They're not looking at a swarm, they're looking at single spiral galaxies. One galaxy spinning like a pinwheel.
And here is the intuition, and it's beautiful. Think of the solar system. Mercury, close to the sun, whips around fast. Neptune, way out at the edge, crawls. The further out you go, the slower you move. That's how gravity is supposed to work when the mass is bunched up in the middle.
Because almost all of the stuff, the sun, is in the center.
Right. So Rubin looks at a spiral galaxy where all the bright stuff, all the stars, are crowded toward the middle, and she expects the same thing. Stars near the edge should be slow.
And they're not.
The outer stars move just as fast as the inner ones. The curve goes flat. It's as if Neptune were racing around at Mercury speed. It makes no sense. Unless there's a huge amount of unseen mass spread all the way out past the visible edge, holding everything at that speed.
A halo.
A halo. That's the word. Every spiral galaxy appears to sit inside a giant, roughly spherical cloud of invisible mass, much bigger than the glowing disk you actually see in a photo.
And the thing that gets me, Rubin didn't see this once and shout, "Dark matter." She measured galaxy after galaxy after galaxy, and they all did the same thing.
That's the part that earns it. One weird galaxy is a curiosity. The same anomaly everywhere is a law of nature knocking on the door.
So now we have to talk about what people mean by this phrase, dark matter, because it is honestly a terrible name.
Go on. Why terrible?
Because dark make you think of something black, something dramatic, a black cloud. It's not dark like that. It's invisible. It doesn't glow. It doesn't block light. It doesn't cast a shadow. Light goes straight through it, as if it weren't there.
The precise statement is, it doesn't interact with light at all. Not by giving light off, not by absorbing it, not by reflecting it. Normal matter, you and me, stars, gas, talks to light constantly. That's why we can see any of it. Dark matter is deaf and mute to light entirely.
So, it's not hiding in a shadow. There's nothing to shine a torch on.
Correct. And this is the number one misconception I'd want a newcomer to drop right away. Dark matter is not dark energy. Totally different thing. Unfortunately, similar name.
The naming. Whoever was in charge of naming these things.
Should be gently spoken to.
Dark matter is stuff. It has mass, it clumps, it pulls things together with gravity. Dark energy is the opposite job. It's pushing the universe apart, making the expansion speed up. Matter clumps and gathers. Energy spreads and pushes. Same adjective, opposite behavior.
And here's a thing that surprised me when I first learned it. Dark matter isn't smeared evenly everywhere. It's lumpy. It gathers into those halos around galaxies. Whereas dark energy is thought to be smooth everywhere, the same in every empty patch of space.
Okay, so roughly, if we're doing the pie chart of the whole universe,
roughly, and these are the standard figures, about 5% ordinary matter, the stuff we can see and touch. Something like 27% dark matter, and the rest, the big slice, around 68% dark energy.
So the two things we understand least are almost the entire pie.
The furniture in one room. I told you.
Now, I said I'd keep asking. Here's the honest challenge. Everything so far is things move faster than we expect. What if we're just wrong about gravity? Maybe there's no invisible stuff. Maybe the formula for how gravity works just breaks down over huge distances.
And that's a serious idea, right? That's not a crank position.
It's a real, respectable minority position. It goes by names like modified Newtonian dynamics, MOND, and its cousins. The idea being tweak the law of gravity at very low pulls, and maybe you don't need any dark matter at all.
But here's where it gets. Okay, this is my favorite piece of evidence in the whole subject. The bullet cluster.
Oh, do this one, Victor, because I've read the name 100 times and I've never had someone just tell me the story.
So, take two galaxy clusters, two enormous swarms, and they crash into each other. A cosmic collision playing out over millions of years. Now, a galaxy cluster is made of three things, roughly. The galaxies themselves, a huge amount of hot gas between them, and, if it exists, the dark matter.
And the key point is, the gas is actually most of the ordinary mass, more than the stars.
Yes, the gas is the bulk of the normal stuff. So they collide, and when they pass through each other, the gas clouds slam together. Gas is sticky, it drags, it piles up hot in the middle. But the galaxies themselves and the dark matter, if there is any, they just sail straight through because they barely interact. They're spread out. They don't slam.
So after the crash, the normal matter, the gas, gets stuck in the middle, and the other stuff sails on ahead.
Right. So now the question is, where is the mass? Where is the gravity really coming from?
And this is where a beautiful tool comes in, gravitational lensing.
Explain that one, because that's another word people hear and nod at.
Mass bends light. That's from Einstein. A big enough lump of mass warps space around it, and light passing by gets bent, like the way a wine glass bends what's behind it. So if you look at distant galaxies behind a massive object, their images get smeared and distorted. And from the pattern of that smearing, you can map where the mass is. You can literally weigh something you cannot see.
Which is incredible on its own. You're mapping the invisible by watching how it bends the light of things behind it.
So they do this to the bullet cluster, and the answer? Most of the mass is not where the gas is. The mass is out with the galaxies that sailed through. The gravity and the visible normal matter are in different places.
Oh, so the gravity got up and walked away from the glowing stuff.
The gravity walked away. And that's very hard to explain if all you're doing is modifying gravity. Because modified gravity says the pull should track the visible matter, the gas. Instead, the pull is somewhere else entirely.
I'll be fair to the other side. The modified gravity people have not given up. And there are things dark matter explains poorly too. But the bullet cluster is the single cleanest reason most physicists think there's actually stuff there, separate from the light.
Okay, so let's say most of the field agrees there's stuff. The obvious next question is the one a kid would ask. What is it? Can we grab some?
This is my salt mine. This is why people are sitting a kilometer underground in the cold.
Tell me why they're down there, because that's such a strange place to look for something that fills the whole galaxy.
So the leading idea for a long time was a particle. A nickname you'll hear is a WIMP, a weakly interacting massive particle, WIMP. The idea is these particles are streaming through everything all the time, through the Earth, through you, right now, billions of them, and almost never bumping into anything.
Almost never being the operative, painful phrase.
Almost never. So the whole game is build an incredibly sensitive detector, usually a big tank of something like liquid xenon, and wait. Wait for one of these ghost particles to, once in a great while, knock into a single atom and give off the tiniest flash of light or spark.
And you go underground because
up here, on the surface, you're being pelted constantly by cosmic rays and background radiation, ordinary junk that would drown out the one flicker you care for. A kilometer of rock over your head is a shield. It filters out the noise so the one whisper can be heard.
A kilometer of rock, and then you still line the detector with the purest materials on Earth, and you wait for months, years. It is the most patient science I have ever witnessed.
And this is the part I want to be honest about. Have they found it?
No, and I think that has to be said plainly. Decades of these experiments, each one more sensitive than the last, and no confirmed direct detection of a dark matter particle. Not a WIMP, not so far.
See, and that's where I get a bit... I don't want us to sell certainty we don't have. We keep saying the leading candidate, but the leading candidate hasn't shown up in 40 years of looking, and I feel like people gloss over how big a deal that absence is.
Hang on, though. I don't think anyone here is glossing it. I said plainly, it hasn't been found.
No, you're right. That came out sharper than I meant. I think I've just read too many articles that go, scientists are closing in, and then nothing for years, and it gets under my skin a little.
No, and it's a fair nerve to have. There's a real difference between we haven't found the particle and we haven't found the mass. The evidence that something is out there gravitationally, the rotation curves, the lensing, the bullet cluster, that's genuinely strong. What's unsettled is what it's made of. Those are two separate questions, and the headlines mush them together.
Yeah, that's the distinction I was reaching for in swinging at you instead. Sorry, Daniel.
Nothing to forgive. Honestly, the wimp not showing up has pushed people to take other ideas seriously, which is healthy.
Right, like the axion, another candidate particle, much lighter, hunted with a completely different kind of experiment, more like a very sensitive radio tuned to catch it converting into a faint signal. And some people wonder about primordial black holes made in the very early universe.
Though the black hole idea has been squeezed pretty hard by observations. It's not ruled all the way out, but it's under pressure. The point is, the field has genuinely widened the net.
So let me ask the why should anyone care question. Because a listener could reasonably say, okay, invisible stuff in space, floating around, doesn't touch me. Why does it matter?
Because you would not exist without it. That's not poetry, it's structural.
Say more.
In the early universe, everything was almost perfectly smooth and nearly even soup. For galaxies to form, you need something to start gathering that soup into clumps, pulling it together with gravity so stars can light up. And ordinary matter alone was too smooth, too jostled by light to clump fast enough.
This is the scaffolding idea, and I think it's the most underrated part of the whole story. Dark matter, because it ignores light, could start clumping early before ordinary matter could. It built the gravitational wells, the valleys, and then ordinary gas rolled down into those valleys and formed the galaxies.
So the dark matter laid the foundations, and the visible universe got built on top.
That's the picture. The cosmic web, those vast filaments and voids, the largest structure we can map, traces where the dark matter went first. We're living inside a structure that invisible mass sketched out billions of years ago.
You are furniture that rolled into a valley you can't see.
I'm going to be thinking about that for a long time.
And there's independent confirmation of this that I find hard to argue with. The cosmic microwave background, the leftover glow from the early universe. When you study the tiny ripples in that glow, the pattern only fits if there was a lot of matter that didn't interact with light doing the gravitational work. It's a completely different measurement than rotation curves, and it lands on a similar amount of dark matter.
And that's the thing that convinces me, honestly. It's not one clue. It's the galaxy spins and the lensing and the bullet cluster and the ancient glow, all separate roads.
All pointing to the same missing house.
When independent methods that could easily have disagreed all converge, that's usually nature telling you you're onto something real, even if you can't yet say what the something is.
So where does that leave us? Because I feel like we've walked someone from invisible stuff, sounds made up, to actually a mountain of evidence. But the honest ending isn't tidy.
No, and I'd resist making it tidy. The honest state of things, we are very confident there's a large amount of mass we can't see, holding galaxies together and shaping the whole universe. We are genuinely not sure what it is. Both of those are true at once, and a good newcomer should hold both.
And I find that thrilling, not frustrating. Think about it. This is not a settled museum piece. This is a live mystery, right now, with people a kilometer underground in the cold, tonight, waiting for one flash of light.
There's something humbling in it too. We built this whole civilization, we split atoms, and we look up and most of what's out there is a stranger we've never touched.
A stranger we can weigh, though. We can't see it, we can't catch it, but we know its weight from how it bends the light of things behind it. That, to me, that's the human thing here. We refuse to just say unknown and walk away.
And the ideas that might crack it are still on the table. The axions, the deeper detectors, and yes, even the possibility that part of the answer is gravity behaving in a way we don't fully understand. I don't think that's likely to be the whole story, but I'd be a bad scientist to slam the door.
So if you take one thing from this, dark matter isn't a spooky ghost, and it isn't a mistake. It's a placeholder name for a very real weight in the universe that we've measured half a dozen ways and haven't yet held in our hands.
5% visible, and we're not embarrassed by the 95. We're going after it.
That's a good place to leave it. The furniture, the valleys, and the patient people in the salt mine. Thank you both. I genuinely came in thinking I understood this, and I'm leaving knowing exactly which parts I don't, which is better.
That's the right way to leave it.
Until the flash of light.
This episode was generated with AI by Demades.